Harness engineering is how we build systems around large language models and turn them into effective software factories. Effective coding agents are comprised of the large language model it uses and the harness around it. We don't control the model, but we do control the harness. The harness is everything around the model, which includes the instructions we give it when it starts a task, the tools, skills, and MCP servers that it's allowed to call, the commands it's allowed to run, and the checks it can fire when it edits files. Imagine you have a new starter on your team. They may know the language that your team uses better than you, but they've never seen your code base. They don't know how to run it, how to test it, or even how it works. That's essentially where a harness can come into play. Let's take the following ASP.NET Core Web API that we're using for a bookstore as an example. The first thing we'll add is an Agents.md file at the root of our project. This is the file that the coding agent will read before it starts a task. Now in this file, we've got a set of startup rules that it uses before writing any code, so it needs to complete these steps in order. Then we define our layer boundaries. So in our API, only the HTTP surface will register routes. Handlers will depend on our service layer and never the repository layer. And the book repository is the only type that will touch the DB context. Then we define some project conventions, so ISBNs are strings, never numeric types. Every abstraction is an interface next to its implementation, and then unit tests substitute the interface below the type under the test. So they're just some normal project conventions. Then we define the commands that the agent can run. So to build the project, we run .NET build. To run the tests, we run .NET tests. And we can even run one test by name by providing the filter, and then we can run the API like so. The next piece is our init shell file. This will run once before the agent starts. It checks if the .NET SDK is there, it then restores and then builds the project. This is the initializer pattern based on Anthropic's work on long-running agents. And the idea is that we hand the agent an environment that already works, so it isn't debugging our build before it gets to the actual task that we assign it. We then have this feature list JSON file. And this is where the agent will track progress. So each feature here has an ID, a summary, acceptance criteria, and the command that verifies it, and the status of whether it's done or not. So this one we've already done, so expanding the book model, and it provides some evidence for that task being done. But for tasks that haven't been done, we've got this to-do status. So this is the source of truth of what's left to do. Now this is a JSON file that sits within our repository. This can expand to a backlog sitting in GitHub or in Jira. The last piece of the puzzle are the hooks. Everything that I've shown you is just guidance, and the agent can still ignore this. Hooks are code that run automatically when something happens, so it applies every time regardless of what the agent decides to do. Since we're using GitHub Copilot, ours live in the GitHub hooks folder, and we've got this verify.json hook. Essentially, it's a JSON config that hangs off a command postToolUse with a matcher, so it only fires on an edit or a create, and it points it at a script. And I've got a bash version for this, which essentially runs the tests to make sure that our changes haven't broken any tests. And there's also a PowerShell script in there as well. And this is something called a sensor. The rule of thumb is that success is silent and that failure is verbose. We're not filling the context for our agent with passing test runs. The agent will only hear from the hook when something has been broken. So we've got a harness, now let's put it to work. We're going to run this in the GitHub Copilot CLI. I'm going to give it a very simple prompt. So implement the query books endpoint. This is one of the features that I have defined in my feature list JSON. There it is. So we should see a get books endpoint, which supports filtering by genre, publisher, country, format, and a price range. We've got our success criteria there, and also verify it with .NET tests, but we're not telling the agent this. So I'll get out of that, just full screen that bad boy again, press enter. We'll let that cook and see how it works through our problem without it actually giving it that much detail. Okay, so our agent has finished running, and it started off by reading the project docs and the current state as required. We didn't ask the agent to go and do that. That's come out of the startup rules that we've defined in our agents.md file. And it's never opened that file because the CLI has already loaded it. So what it will do, it read the feature list JSON file to find the feature. Then it's taken a look at the architecture and product MD files, and then it's worked through the source files. We then run the init shell bash, or the agent, has run the init shell file to check that the build is clean. And before it writes a line of code, it's reading the existing tests to pick up the conventions that we use. Now, it didn't didn't follow our startup rules in the exact order that we wrote them. It went to the feature list first, then it looked at the architecture and the product MD files, and then it ran the init script a bit later than we asked for. So it did all of it just in its own order. And then it starts building, and this is where the layer boundaries are doing the work. So it's gone ahead and created a book query record for the filters. The where clauses will go in the repository, one per filter, and then the handler binds the query string with as parameters. And then the root registration goes into the extensions class here rather than the program.cs file. Now, at one point, it stops and works out that the trimming and lower cases belong into the service. And because that's a catalog rule, the catalog rules live in the service layer. And that's a line out of our agents.md file turning up in the agent's own reasoning. It then writes the test, so it's created the query books test file, and then it builds and runs the unit tests, and it gets 14 tests passed. So it's written 14 tests, and they all passed. And then it does something that we didn't ask for explicitly. It starts the API up and it executes a curl command against it because it decided that the riskiest part was whether as parameters really binds from the query string. It goes through the acceptance criteria against the running app and the genre matching case insensitivity to filters combining with an unmatched filter, returning an empty array with 200 rather than 401. And then the last one is written in feature list JSON word for word. So if I just open up that feature list file, I should see now in our query books endpoint, it's written that as evidence. So get books takes an optional genre, publisher, country, format, min price and max price through a new model's book query record bound with as parameters. So if I go into the models, look at the book query file, I can see that record there. Go back into the feature list JSON file, and then the book service, find book asyncs, trims and lower cases, the text filters and short circuits to get all async with no filter is supplied. So let me go into the book service in our service layer. And I can see some normalization happening there with the strings, which looks pretty good. So if I go back into that feature list JSON file again, the book repository find async composes one where statement per supplied filter over as no tracking query. So filters combined with and still orders by title. So if I look at that find async method in the repository layer, I can see that those queries are concatenated together with and. So I've got where for genre, publisher, country, format, the price and the max price. So that's all working as expected. So we can see the changes there, and we can also see the verifications that it's run in accordance with our agents.md file. And that's our harness at work. So that's not coming from a better performing model. I'm using Claude Opus 5, which is a pretty powerful model, but none of that is derived from the model itself. That is derived from our agents.md file, as well as our init script to start an environment or initialize our environment for the agent to run in, as well as our feature list JSON file, which defines our features, our acceptance criteria, and then how we can actually verify whether that feature has been properly implemented. So there is a very basic harness. We have an agent.md file with its rules. We have an initialization script that gets the environment ready. And then we also have a feature list JSON file, which defines what done means. And then we also have hooks up here, which checks the work after every single effort. Now this is very basic, and this grows through making mistakes. So every time you find that an agent has made a mistake, you take the time to engineer a solution such that the agent will never make that mistake again. So we don't sit down and design a perfect harness up front. We watch the agent get something wrong, and then we encode that to stop it from happening again. And there's plenty of room to expand from here. So we only use one hook event, and GitHub Copilot CLI, or GitHub hooks, have about 8 of them. We can also add skills as well, which are skill.md files that the agent can load only when a task needs to use them. So these are reusable knowledge skills that stays out of the context window until it's actually needed. And we can also use MCP servers to give the agent tools it doesn't have on its own. So I talked about how this feature list.json file could actually be sitting on a backlog in GitHub on Jira, and there are MCP servers that can hook into those particular services so we can call them rather than just having everything in a JSON file locally in our repository. So that wraps up this video. If you liked it, give it a like, and if you want to see more .NET, Azure, or AI engineering content, don't forget to subscribe. If you have any questions, pop them in the comment section below. This repo will be up on my GitHub, and I'll add that link and all the other resources in the video description. Until next time, happy coding.